Thanks for watching. If you enjoyed this video, please hit the subscribe button and ring the notification bell so you never miss an update. Leave a comment below to help grow the channel, and don't forget to smash the like button.
Okay, Lecture 7, divisibility. So today we're going to talk about divisibility. And that is the question of, does one number divide another number? So for example, is 4 divisible by 2? I see a shaking of the head. You think 4 is not divisible by 2. I think you thought was 2 divisible by 4, but 4 divisible by 2 means that 2 divides 4, which means that 4 divided by 2 equals a whole number with no remainder. So if a number is divisible by another number, then it divides it evenly. So for example, 4 divided by 2, if I divide 2 into 4, 2 times 2 is 4, the remainder is 0. If I try to divide 2 into 5, however, right, 2 will go into 5 2 times. 5 minus 4 is 1. That leaves a remainder of 1, and so the answer is 2, remainder 1. So 5 is not divisible by 2. Divisible by 2, even ones place. Now, I'm not going to prove to you in this lesson why that's the case, that if we simply look at the ones place of any number, if the ones place is an even digit, 0, 2, 4, 6, or 8, then that number is divisible by 2. It obviously works for numbers like 2, 4, 6, and 8, because we know that those are all multiples of 2, yes? But what about a bigger number? Like pick a number in the 20s. Give me a number.
25.
25. So we write down 25. Yes? The ones place, what's in the ones place of 25? That's a 5. Is 5 a 0, a 2, a 4, a 6, or an 8? Okay. No, it's not. And so that means this number must not be divisible by 2. And we can, of course, test it using our long division skills, right? Divide 2 into 2 goes 1 time. 2 times 1 is 2. 2 minus 2 is 0. It's looking good so far, huh? Now drop down the next digit. 2 into 5. Well, 2 times 2 is 4. 4 minus 5 is 1. Oh, no. We get 12, remainder 1. So 25 is not divisible by 2. But we can know that by simply looking at the ones place. There's no reason to look anywhere else. Now, the technical reason for that has to do with modular arithmetic, and I'm not going to go into that in this lecture. So let me give you one to try, all right? And we can try it at home. I want to know, is 354 divisible by 2? Is that evenly divisible by 2? Or just divisible by 2? So give that a try at home. Think about it for a second. Pause the video. Come back when you think you've got it. Okay, the short answer is yes, it is divisible by 2. And how do I know? Because in the ones place, I see a 4. And I already said that if the ones place contains one of the even digits, 0, 2, 4, 6, or 8, then the whole number is divisible by 2. But of course, we should check it just to be sure, because you never know. So let's divide this by 2. 2 goes into 3 one time. 1 times 2 is 2. 3 minus 2 is 1. Drop down to 5. 2 goes into 15 7 times. 7 times 2 is 14. 15 minus 14 is 1. Drop down the next digit, 4. 2 goes into 14 7 times. 7 times 2 is 14. Remainder is 0, so 354 divided by 2 is 177. Now, of course, if you mastered the techniques, was it lecture 1 or lecture 3? I think it was lecture 3, where we talk about division, having numbers, right? Then you could get this answer just by simply having these. Half of 3 is going to be 1. Half of 5 is going to be 2, but with an odd left neighbor, you use the 5's conjugate, so that's 7. And then half of 4 is 2, but with an odd left neighbor, we use the 5's conjugate of 2, which is 7, so we get 177. Okay, you could do that in your head very quickly. All right, so divisibility by 2 is pretty straightforward. Just look for an even digit in the ones place. Now, I'm going to do this in order, by the way. There's probably a more sensible order to do it in, but I'm going to just do these numbers in order. So now what about divisibility by 3? Oh, no, I skipped a very important one, divisibility by 1. But remember from our last lecture on prime numbers, right? Every number is divisible by 1. So, yeah, exactly. So no reason to talk about that. The divisibility rule for 1 is it a number? If the answer is yes, then it's divisible by 1. All right, divisibility by 3. That's a funny rule, and we'll see something similar to it later on when we get down to a bigger digit. But divisibility by 3, it basically works like this. Take the number whatever it is. So it's easier to see it by example. So let's just invent a number here. Let's do 72. I chose that number because if I chose like 12, you'd be like, oh, well, of course it's divisible by 3 because 3 times 4 is 12. But I picked a number that maybe you don't recognize immediately if you try to divide it by 3 what the answer is and whether it has a remainder or not. The trick to figure out if a number is divisible by 3 is to add up the digits. Well, that's easy. What is 7 plus 2?
9.
9. And then you ask, is the sum of the digits equal to a number that's divisible by 3? Yes, it is. 9 is divisible by 3. Therefore, 72 must be also. So we can test it just to verify. 3 into 72. 3 goes into 7 2 times. 2 times 3 is 6. 7 minus 6 is 1. Drop down the next digit. 3 goes into 12 4 times. 4 times 3 is 12. And so 12 minus 12 is 0. There's no remainder. We see it's evenly divisible. So 24 times 3 is 72. So 72 is divisible by 3. So let me give you one to try at home. 459. Divisible by 3? Yes or no? Pause the video, think about it for a second, come back when you think you know. Okay, so we have to add up the digits and see if it's a number that itself is divisible by 3. If it is, then this number is divisible by 3. If not, then it's not divisible by 3. So 4 plus 5 is 9. And then we have another 9. What is 9 plus 9?
18.
18. So we see that 18, so I'll write that the sum is 18. And maybe haven't mastered my multiplication tables yet, so I don't know that 6 times 3 is 18. I know it is, but I'm just saying, pretend that I don't. And I'm like, well, gosh, the teacher told me that all I had to do was add up the digits, and if I should get a number that I can easily tell if it's divisible by 9 or not.
1 to the 8.
Yes, we can repeat the procedure. That's correct. So 1 plus 8 is 9, and 9 is divisible by 3, right? The single-digit numbers divisible by 3 are, 0, trivially, 3, 6, and 9. So we're looking for 0, 3, 6, or 9. If we can get these things to add up to those, then we're good to go. So yes, 459 is divisible by 3. And I'll let you partake of the joy of dividing 3 into that to see that it's true. Let's move on to the next digit. But first, let me summarize that here. Let's write the sum of digits is divisible by 3. Okay. What comes after 3? What comes after 3?
4.
Good. Divisibility by 4. Well, remember how when we looked at divisibility by 2, I told you that only the ones place matters? Well, when you divide numbers by 4, it turns out that both the ones and the tens place are important. So there's a rule that you can use, but there's the way I usually do it, to be honest with you, is I'll just simply have the number in question, and if that's divisible by 2, then it's divisible by 4. Let me show you what I mean by that. Let's say we know if it's not an even number, right, then it's not going to be divisible by 4. Because 4, when you factor it, is 2 times 2. That means that it's the atoms that make up the molecule known as 4, right, that composite number, 4, they are both 2, which means that 4 has the property of evenness, okay? We find that composite numbers take on the property of the prime numbers that make them up. And 2 is the prime number that makes up 4, and it is characterized by evenness. And so the rule for evenness has to apply to some degree. So if we get a number that is not, whose ones place is not an even digit, 0, 2, 4, 6, or 8, then it's not divisible by 4. But let's pick one like, say, 32. Well, it is even, right? But the question is it divisible by 4? And so the kind of the shortcut that I like to use is I simply half this number. Half of 32, anyone know what that is?
16.
16, right? If you half the number and you get a number that's divisible by 2, then the original number was divisible by 4. Now, the other way to do it is to take both the tens place and the ones place into account. And so basically it's like this. If the tens is odd, then we're looking for in the ones place either a 2 or a 6. If the tens place is even, then we're looking for a 0, 4, or an 8. The hundredths place, thousandths place, doesn't matter at all. All right? So if I wrote down a number like, I don't know, 1,148. Is that divisible by 4? Well, we look at the tens place. It's even. If the tens place is even, then the ones place must be a 0, 4, or 8 for this to be divisible by 4. It's an 8, so it is. What about this one? 962. Looks like something that ought to be divisible by 4, but let's try. Try it at home, pause the video, come back when you think you have an answer. So again, we look at the tens place and we say, well, that's even. If it's even, then our rule tells us that for this to be divisible by 4, this has to be either a 0, 4, or 8. It's a 2. So this is not divisible by 4. So let's check it just to prove ourselves right here. So we'll divide 4 into this. 4 goes into 9 2 times. 4 times 2 is 8. 9 minus 8 is 1. Drop down the next digit. 4 goes into 16 4 times. 4 times 4 is 16. That gives me a remainder of 0. Drop down the next digit. 4 goes into 2 0 times, and so we'll end up getting 240 remainder 2. Not divisible by 4. The other way you could have approached this is you could have said, okay, well, let me just have this number. And here's a little trick you can do when having these numbers. You can look at the last two digits, right? If I have a 9, that's like halving an 8, so it'll get halved to 4, right? When I have a 6, I get 3, but I got an odd left neighbor, so I take the 5's conjugate of that, so I'll get an 8, because the 5's conjugate of 3 is 8. So 4, 8, and then I half the 2, I get 1. My left neighbor is even, so I don't change it. It's just going to be a 1. And any number that ends in 1 is not divisible by 2. So because when I half this, I get a number that's not divisible by 2, this number is not divisible by 4. All right, divisibility by 5. Well, this is one of the easiest ones of all. A number is divisible by 5 if it ends, if its ones place, is either a 0 or a 5. So 28, is that divisible by 5?
No.
Absolutely not, because the ones place is an 8. It would be divisible by 5 only if the ones place had a 0 or a 5. How about this one? Is that number divisible by 5? Anybody? Right. Pause the video, think about it at home, come back when you've got the answer.
Wouldn't it be nice if you could just look at an arithmetic problem and know the answer? Wouldn't it be nice if it was as easy as reading off the digits? Wouldn't it be nice if large numbers were no more difficult than small numbers? They just take a little longer to rattle off the answer. This is exactly what the method in digit-by-digit arithmetic achieves. For example, you can multiply by 5 by simply reading off half of each digit from left to right and adding on a 0 when you're done. For 2 times 5, you would simply say 10 because half of 20 is 10. Digit-by-digit arithmetic, fast math to minimize working memory strain.
Welcome back. Anyone have a guess as to whether this huge number is divisible by 5 or not?
Yes.
What do you think is the answer?
It is.
It is divisible by 5. Why? Because the ones place is a 5. And if it's a 0 or a 5, then the whole number, all this stuff up here, I put a bunch of 5s into tricky, but all this stuff here, not relevant, okay? The only thing that matters is here. If it's a 0 or a 5 in the ones place, it's divisible by 5. There you go. One more divisible by 5 problem. There. Pause the video, come back when you've got the answer. Is this number divisible by 5?
No.
No, it's not. I tried to throw you off with all these 5s I put in there, right? But the only thing that matters is this ones place, and the ones place is a 3. So that's not divisible by 5. So for divisible by 5, I'm just going to write ones place, 0 or 5. Divisibility by 6. Now this is an interesting one. This is one of my favorite ones because it really captures the essence of what prime numbers, what their influence is. Right? When I say that composite numbers are molecules that are made up of atoms that are the prime numbers, this is what I mean. 6 is a composite number. Okay, it's not a prime number. If we factor it, what does it factor as? Start with the first prime, 2. How many 2's go into 6? Well, that's 3, but 3 is a prime. So the prime factorization of 6 is 2 times 3. right? Which means that 6 will have both the properties of 2 and the properties of 3. So that means that in order for a number to be divisible by 6, it's going to have to be divisible by 2, and it's going to have to be divisible by 3. Things that are divisible by 2 in their ones place have even numbers. Things that are divisible by 3, they're digits. When you add them up, they sum up to something that's divisible by 3. So we can take a number like, I don't know, let's do 126. Yes?
Yes.
Do you think it's divisible by 6, just by looking at it? You kind of want to think it is because of the 6, right? So, but we have to check it. For check number 1, it has to be divisible by 2, because 6 is composed of the primes 2 and the prime 3. So it has to be divisible by 2. Is it divisible by 2? Yes, it is, because the ones place is a 6, and that's an even digit. So good to go on that one. Now we have to test whether it's divisible also by 3. Well, that means we have to add the digits up. So 1 plus 2 is 3, plus 6 is 9. That's divisible by 3. Therefore, 126 is divisible by 3 as well. If it's divisible by both 2 and by 3, then it's divisible by 6. And so we can just check that. 6 goes into 1 no times, but it goes into 12 2 times. 2 times, this is 12. 12 minus 12 is 0. Drop down the next digit. 6 goes into 6 1 time. 1 times 6 is 6. Evenly divisible. So let me give you one to try. Yeah, I like that one. So pause the video, give it a think, do the 2 tests that you know you need to do to figure out if this is divisible by 6. So the first test we do is the even test, right? Is it divisible by 2? Well, yes it is, because the ones place has a 0, and that's one of the even digits. Next we have to ask, is it divisible by 3? Well, we just add up the digits. 4 plus 5 is 9, plus 0 is still 9. So yes, it's divisible by 3, and that means it must be divisible by 6. And I'll let you try that at home to verify that that's the case, and we'll move on to 7. But first let me summarize divisibility by 6, divisible by 2, and 3, because 6 is made of the 2 primes, 2 and 3. All right, divisibility by 7. Technically, there is a way to test for divisibility on numbers that might be divisible by 7, but honestly, it's not worth the effort. If you have a number and you want to know if it's divisible by 7, just divide it and see. 7 are a pain, so just try it. Okay? Just try it. All right, next up is divisibility by 8. Well, as it turns out, 8 follows a very similar pattern. Let's factorize 8, right? Remember that we can factorize 2 as just, 2 times 1, so this is just equal to 2 for its factorization. 4 factorizes as 2 times 2, which means 2 times 2 is its prime factorization. And then 8, if we factor that, we start with 2. 4 times 2 is 8, but 4 is also divisible by 2. And so we see that 8 is 2 times 2 times 2. You see that? So for numbers divisible by 2, the ones place has to be an even digit. And we only have to consider the ones place. To test for divisibility by 4, we had to check both the ones place and the tens place. And for divisibility by 8, it turns out you need to check the ones place, the tens place, and the hundreds place. Does that make sense? And there is a formal rule that you can get, but I'm not going to actually use that. What I'm going to suggest here is you want to take the number. Let's pick a number and let's just work with it and see. Let's pick a large number like 89,000, 424. I'm just making this number up, okay? So I don't even know yet whether it's going to work, but let's try it. So first things first. If we're testing for divisibility by 8, the only thing that matters are these 3 digits here. You see that? We can completely ignore these. Almost, with one exception, okay? Because what I want you to do with a problem like this is I want you to half this number. But you don't have to half the whole thing. You just need to half this part here. But you need to take into account the neighbor. This is an odd number. When we have odd neighbors, when we have things, it's kind of funny. Half of 4 is 2, but we have an odd neighbor, right? So it's not 2, but 7. Then we half this. Half of 2 is 1. And then we half this. Half of 4 is 2. And now we ask the question, is that divisible by 4? Well, is it? Well, the only thing that matters is the tens place and the ones place, right? And our divisibility by 4 rule tells us, well, if the tens place is an odd number, like it is, then we can have a 2 or a 6 in the ones place for this to be divisible by 4. And we have a 2, so this is divisible by 4. So that means that this number should be divisible by 8. Let's see if we got it right. I get rid of the comma because it's not useful when doing long division. And then we'll just divide 8 into this, see what we get. 8 goes into 8 one time, leaving a remainder of 0. Drop down the next digit. 8 goes into 9 one time, leaving a remainder of 1. Drop down the next digit. 8 goes into 14 just one time, right? 8 times 2 is 16. So 14 minus 8 is just going to give us 6, right? Drop down the next digit. 8 goes into 62. It almost would go into it 8 times, but instead it's only going to be 7 times. 7 times 8 is 56. And who can tell me what 62 minus 56 is?
6.
6. Drop down the next digit. 64. How many 8s go into 64? Exactly 8. 8 times 8 is 64. Yeah? So what if we had 4? 28. Divisible by 8? We want it to be because it has an 8 in it, right? So try it at home. Come back when you think you've got it. So what do you think? Divisible by 8?
Yes.
Oh, I get the thumbs up in the back. Well, let's half it. Well, half of 4 is 2, so that's 2. Half of 2 is 1. Half of 8 is 4. Is that number divisible by 4? Well, it's got an odd number in the tens place, which means that in order for this to be divisible by 4, this must be a 2 or a 6. It's not. So this is not divisible by 8, even though I put that 8 there to trick you. So if I try to divide 8 into this, 8 goes into 4. Well, it doesn't, but 8 goes into 42. We can get it in 5 times. 5 times 8 is 40. 42 minus 40 is 2. Drop down 8. 8 goes into 28. Well, no, it doesn't. 3 times will get me 24 with a remainder of 4. So as you can see, 428 is not divisible by 8. So I'm going to say half it. Check if divisible by 4. All right, that brings us to divisibility by 9. Is a number divisible by 9? And this is interesting because if we factor 9, what do we see? 9 factors as, well, 2 doesn't divide 9. We know that because it's not even, right? So we'll try a 3. And 3 times 3 is 9. Both of them are prime, which means the prime factorization of 9 is 3 times 3. Which means it's going to have the same quality or characters of things that are divisible by 3. And it does. And it turns out the consequence of it being repeated twice, 2 3s, means that the sum of the digits has to be divisible by 9 itself. Okay? So let's do a simple one first, like 18. We know 18 is divisible by 9 because it's 9 times 2. If we add the digits up, what do we get? Well, 1 plus 8 is 9. You see? This is the easy way to, whenever you're doing multiplication, if you want to do 9 times 3, we just remember that the fast way to do it is we say, well, the 3 is going to mean it's in the 20s. We always decrease that by 1. So it's 20, and then we have to ask, what do we have to add to 2 to get 9? That'd be 7, so it must be 27. How about 6 times 9? Well, 6 means I'm going to be in the 50s. What do I have to add to 5 to get 9? That's 4, so it must be 54. You see? So yes, 18 is divisible by 9. The sum of the digits actually add up to 9. Let's pick something that's a little harder. Maybe 345. That doesn't look like it's divisible by 9, does it? What do you think?
No.
It's not, because 3 plus 4 is 7 plus 5 is 12. If I don't know if 12 is divisible by 9, I could add up the digits just like we did with 3. You can repeat this process. 1 plus 2 is 3. It's not divisible by 9. But what if this, instead of being a 3, was, say, a 9? Is 945 divisible by 9? Well, yes, because 9, well, 4 plus 5 is 9, and 9 plus 9 is 18. And I can repeat the process again. If I don't know that 18 is divisible by 9, I can add 1 plus 8 to get 9. That is divisible by 9, yes? So 945 is divisible by 9. One for everyone at home. Let's see. Yeah. So pause the video, see if that guy is divisible by 9. Come back when you think you've got it.
No.
All right, so all we have to do is add the digits up. So we have the 2 and the 6. 6 and 2 is 8, plus 1 more is 9, plus 1 more is 10. So no, this is not divisible by 9. All right, sum of digits divisible by 9. That's the rule for divisibility by 9. If the sum of the digits is divisible by 9, then so is the original number. That brings us to the last one I want to talk about, which is divisibility by 10. And this is the absolute easiest number to test for divisibility. The rule for is a number divisible by 10 is, does it end in 0? If it ends in 0, it's divisible by 10. Pure and simple. So, this 38, divisible by 10? No, it's not, right? You can see, right? If you would imagine doing long division on this, you'd see, well, you'd say, how many 10s go into 38? I can get 3. 10 times 3 is 30 with a remainder of 8, right? Whatever the ones place is, that'll be the remainder. You want a remainder of 0, right, when you divide by something. So 38 is not divisible by 10. How about 430? Divisible by 10?
Yes. What?
Oh, good. Yes, it is divisible by 10 because the ones place has got a 0. Okay, so if I try to divide this in, I can see, well, 43 times 10 must be 430, right? Okay, so divisibility by 10 is the easiest. It ends in 0. In this lesson, we've learned how to discern whether a number is divisible by 2, 3, 4, 5, 6, 8, 9, or 10. 7, just try it and see, because the rule, though it exists, is rather complicated, and I don't think it's worth learning. This will prove very useful when working on problems, because it's good to know if a number is divisible by another number, especially when we get into fractions, right? This is going to be important. That's all I've got on that. I think that the next lesson will actually be fractions, so I'll see you then.